All right, how we doing, everybody? Doing good, doing good. All right, I'm streaming on Twitch right now, so if my students want to see it, go ahead, be my very guest. So today is gonna be a little active lab to show you what I want you guys to do. So everyone checked out the pre-lab, correct? Right, not too bad. Let's just walk through it, okay? And yes, it's on recording. I'll publish this, and you guys can have fun. Let me see. Did this all make sense? Let me see. Stuff like this, right? Not too bad. Did everyone see the answers? Or whatever this is. Not too hard. Okay? But does anyone know what S is? S is equal to sigma plus j omega, right? For those who are my EEs, those who are my electrical engineering students, you're going to be studying that in 360 next semester. For those who are CPs, I think there's like CP 260 you can take, I think. You can learn about that too, okay? I don't know who teaches that. But anyways, j omega. But I didn't put the sigma because I didn't want to make it too complicated, but there's a thing where the signal dies. Yeah, it dies away, okay? I don't want to show you guys that. Anyways, things are alive and happy. Do you guys understand this right here? Transfer function in terms of frequency, linear frequency, correct? Not too bad. This is how you do your magnitudes, right? Your phase, and then this is how you get your pole, right? Your 3 dB frequency. Everyone can use this little calculation and get their band passes, or not band passes, bandwidths. What's bandwidth? It's just the width of the band, right? Just how long it is. And then let me see. And then yeah, here's a good number 707, or LOL upside down, right? So this is your favorite magic number. What's the 20 log dB of 707? Minus 3 dB. All right, these are two numbers I want you guys memorizing for the rest of your lives. Oh yeah, and don't forget 45 degrees. Did I put that in this lab? Right there. 3 numbers to memorize, okay? Because personally, I think phase is really important, okay? That's what I'm doing my PhD in, okay? What's so important about the phase? A lot of things, okay? Do you guys I put an example on there? Well, one of the examples is correct. The other one may not be correct because I want to make sure you guys don't blow things. Anyways. You guys like that nice little answer? So some of you guys probably are using this too. That's whatever. Anyways. You see that right there? Actually, you see this plot right here, right? You're going to try and draw this on by hand, okay? Funny enough, none of these machines can do this type of plot. Except for this. Yep. That's my special one, okay? Because the dean didn't want me to give me like $40,000 to buy a license for every one of these ones. So I'm like, come on, I want to do this. I want to show plots, but it's okay. 221 students are gonna have to do it by hand, which is it's not that bad. Last year's or the predecessor made you guys do 10 frequencies or 20 I don't know how many it was, but it was super like tedious, and you were like, why am I doing this frequency when I know it's gonna be 0? So my objective is you're gonna attack the band with itself, the 1 over 2 pi f or 2 pi rc, and then you're gonna pick a point under it and a point below it or above it, and then maybe a couple more, okay, just to like draw this pretty graph, not just for the voltage, the magnitude, dB, but the phase. Does that make sense? And I'm gonna show you what's gonna go on because this machine does something I don't think you guys are gonna see. This one does a much better one, okay? Anyways. And then Bodhi plots. I was gonna make you guys do Bodhi plots, but I'm like, it's if you understand it, be my guest. If you don't, don't try. But anyways, I give you guys a high pass filter, and then you'll notice it's 1.59 kilohertz, right? But look at my lab. Design a low pass, right? Because we're gonna. What does low pass do? Just passes the low frequencies, right? Does that make sense? And then the high pass passes the high frequencies. Is that cool? Any questions about that? And then you're gonna put the two together. Make sense? And then you get a band pass with this right here. Is that cool with everybody? Anyways, let me see if I can if everyone understands what I'm trying to do. So if I were to do RC right here, right? What's the band or what's the bandwidth? Right? Not too hard, right? And then when you draw your Bode plots, right, or not Bode plots, but you're going to go to, here's F, here's your frequency here. You're going to draw this. On your function generators, these guys right here, you're going to put, I don't know, is it 1.59K, right? And you're going to measure that voltage, okay? What's V out going to be? Do you guys know? 0.707, right? But then you have to convert that to log 3 dB. So 20 log 10 V out over V in, right? Minus 3 dB. And then boom. Right? Does that make sense? And if because it's a low pass, right? It's going to pass everything here, right? And then everything, it just filters out like that. Right? So you're gonna pick another frequency here. Pick, I don't know, 800, right? 800 hertz, and then right here pick, I don't know, pick 10K, right? And then you're gonna see like an ugly little plot, and then that's where you, if you want to, start putting more points. Like, okay, I want to put like a point right here, right? I want to see what that is, right? This might be I don't know, 2K. 2 kilohertz. Does that make sense with everybody? Everyone understand what's going to go on? Should I demonstrate what's going on? Yes? All right. Where's the resistor and the capacitor?
We have...
Let me see.
Ooh, resistors and capacitors.
Let me see. And then I'll show you guys this demonstration right here.
These ones are 20 nanovolts.
Okay. 20 nano?
Yeah.
Okay. 20 nano. And then what's a good resistor?
This is 400.
400? 400 ohms?
Yeah, we need a big...
That's fine. So I've been given a filter. Okay? I'm going to do an RC filter with 400 ohms. Calculator. Or actually, who knows MATLAB? Anybody know MATLAB? No? Except if you're going to be my 360 student? That's what I was hoping to get the measurement. So actually, I'll use this as an example. Everyone's got one of these Keithley function generator or multimeters, okay? So one thing you're going to notice is sometimes the capacitor you're going to get isn't the capacitor that it says it's going to be. So what you're going to do is you're going to do the following, okay? Be like me or something like this. Grab your alligator clips like this. Plus, okay, come on. Plus, minus, and measure your capacitor, okay? Does everyone know how to do that? Yep, measure your capacitor. So then I can do the following, and let's see the capacitor. Press shift, and this little capacitor symbol, it's 22 nano, right? So it's 22 nano, okay? And then what's the resistor? Okay, 22 nano, let's memorize that number. And then let's see, 22, come on, the resistor, press the resistor button. 386. Okay, so I would encourage everyone, I have a whole bunch of banana to alligators. 386 and 22. Okay. Oh, you weren't supposed to see this. This is the answer key for my other class. R is equal to, what did I say? 386 ohms, correct? C is equal to 22 e to the minus 9. Everyone know what e minus 9 is? Nano, right? So 22 nano. Makes sense? Then let's do my F, 3 dB, right? Is equal to 1 divided by 2 times pi times RC. What's this going to give me? Actually, I don't like reading that. Format short engineering. I should rewrite this answer. 18 kilohertz. Everyone see what we're going to do? 18 kilohertz. So at 18 kilohertz, what should I see? That 3 dB, correct? And then here's this component. Here's this other component. And then, oh yeah, you see that right there? That's the special mode. Should I show you guys the special mode? You guys want to see it? Okay. So let me see. I got my capacitor here. Everyone's gonna do this, okay? Or not, I don't know. Well, ideally that's the lab. Okay. RC. And then actually let me show you my 4K camera. Let's see if you guys can see that. Actually, let's get rid of these components. Everyone see that right there? Pretty nice. It's a little out of focus. Cool? So what I'm gonna do right now is I'm gonna probe these guys, and where are my oscilloscope probes? Oh yeah, let me see, where are they? Oh, right here. So some of you guys probably noticed, but some of these probes, I've colored them a little bit. There's these little rings. Let me show you. You see that right there? It's green. And then that means this guy's green here. Makes it a lot easier. Cool. So I'm gonna put this one right here, channel 1. Everyone can see what I'm doing. Oh, sorry, wrong one. There we go. That's my green probe. This is my yellow probe. Okay. See the yellow? Right? Yellow, yellow. Cool. Because you guys get lost with the probes, right? I think this lab might be the weird lab. The other one has the special probes. Okay. So I'm gonna probe here. What am I going to do? Channel 1's going to be right here, right? R, right here, and then this is my ground. Actually, I'm going to make this my ground. Okay. You see this blue rail right here? That's going to be my ground, okay? So I'm going to probe that. Oh wait, I don't even have a probe. Anyways, do we have another cable I can steal? Or not cable, but little wires.
Yeah, there's some right here.
Actually the things I bought. Okay, I'm going to probe that. And then I'm going to probe this one. Thank you very much. Okay. So that one's my V out. This right here is my V in. Give me a second. Okay, and then this right here is my ground. Let me just give me a second right here. Ba ba ba. Boom. And where's the clippy for? Oh, this one doesn't have a clippy. There you go. Who chopped it off? There you go. Give me a second, y'all. This will be worth it. Or no, you guys are thinking it's too easy. Just let me know, okay? Come on. There we go. Everyone see what I'm trying to do? This green one right here is channel 1. Probe to this resistor right there. And then you see that capacitor right there? You see this red cable right here? Right? That right there is connected to this yellow cable right there, and it's right there. You see that? Everyone making sense with what I'm trying to do? What about the function generator? Okay, I have to connect this function generator to that channel 1 probe. Okay, ooh, cute. Then I'm gonna connect this to the output. And I kind of want to show you the cool things, but nah, that might be a little too complicated. Delete, yes, okay. Delete, default setup, there we go. Okay, channel 1, channel 2, okay. And this one, for just this lab, it might be a little weird with this oscilloscope, okay. So what I'm going to do is I'm going to set my waveform to a sine wave, my frequency, let's just leave that. Amplitude, let me show you what I'm trying to do. Can you see that right there? Not really. You guys see that? You guys like this lab? There we go. It's a little dark. Come on. You guys see that? Come on, a little more. There we go. Let me just move it down a little bit. There you go. Cool? I'm going to set this to 2 volts peak to peak, right? Alright, that's what you're going to do on your function generators. And I think that's it. Oh yeah, high Z. Make sure it's on high Z, okay? Because we're dealing with high resistances. Frequency, what did I calculate? 18 kilohertz? Let's just put 18, okay? 18K. Is that cool? And output? Everyone seeing what I'm trying to do? You guys see the output button? Let me see. There you go. You guys like my filter? There it is. Okay, you guys getting your money's worth, huh? Okay, what's this right here? VN? Why did I choose 1 volt peak to peak? Oh, let me see. Don't forget to set your probes to times 1. There we go. Times 10. Sorry, times 10. Everyone see that number right there? That 1 volt. That's why I chose V peak to peak 2 volts. So it goes from 1 to minus 1. Right? Here's my output. Why is it not outputting things? Give me a second, everybody. You know why? Because it fell off. Let me see. Here's that input. Oh. Give me a second right here. There you go. Looking good, right? What's the output voltage? Is that 707? I'm not going to know. So what I want everyone to do, because I don't want to think, press this measure button right here. And then let me just turn down the filter, okay? And then let's try, should we use maximum? Let's use top. Okay, top, add, wait, that's the output. And then let me do channel 2. This is the input. Oh, actually, I think I might like this. Go on, top, add. Do you know why I selected V out over V in, or 1 volt? You see that right there? It's about 1 volt. It's not 1 volt, but it's bothering me. It's okay. 6.68, 648 millivolts, right? Divided by 1 volt. Is that close enough to 707? Do you see why it's not close to 707, right? Let me show you one more measurement, and this is why I think it's important. Press measure, okay? This oscilloscope is a little weird, okay? I'm going to tell everyone you're not going to get negative phase. All right? With this oscilloscope, you're not going to get negative phase. This one right here, you go. So if you have this one, you're in luck. Go down to time measurements. Go to phase. This one here is going to be V in. Okay, source channel 1, source channel 2, right? I'm going to do channel 2 with respect to channel 1. Is that cool? Right? Add. What's the phase? 42 degrees? But it's supposed to be a negative, right? It's not a negative. So don't forget, it's going to be, think of it as for this oscilloscope, think of it as a negative, okay? Does that make sense with everybody? So it's supposed to be minus for be smarter than the machine, okay? So this is what my proposal, this is what I'm trying to do my PhD in, okay? Is I think, do you know how there's noisy signals out there, right? You're not going to get a perfect signal, right? But if the echoes if you look at the echoes, right, the delays, I think that's more important. So like if I snap my finger, you can calculate that, when it's going to hit the wall or something like that, right? Is that correct? So I think what's more important is that 45 degrees, right? So you see how it says 43 degrees right now? So what I want everyone to do is go to your function generator, right here, press frequency, and just move this dial a little bit until you start seeing it say 45 degrees. You see now it's 44, 45, and then you might have to like do a little bit of tinkering. There you go, you see? 45 degrees. But who wants frequency? Just press measure, and then go to time measurements. Go to frequency, channel 1, add. What's my frequency? 19.6. You guys see that right there? So why is it, we calculated, was it 18.62, right? Or something like that. But why is it 19? Parasitics. Everyone understand what's going to go on? So you're going to pick, okay, I'm going to pick this one right here. Then I'm going to do I'm going to choose 1 kilohertz, right? Make sure you move your time thing like this. Okay? There we go. You guys see that right there? What am I at? I'm at 1 hertz. Ew. 1 kilohertz. Is that cool with everybody? And then let me just press this right here. And then what's the output voltage? 980 millivolts, right? Divided by 1. And then do 20 log dB, right? Does that make sense? And then you guys are going to draw your Bodie plots, okay? Is that going to be a fun lab for everybody? Are there any questions for what I'm trying to expect from everybody? No? I can show you with this one, but this one does automatic phase. This lab, I think everyone, just let us know, okay? All right? You guys ready to start the lab? Go home? All right. Have a good day.